grand finale of not only our algebra unit, we will be starting geometry after we take the test on this, but it's also the grand finale of solving equations, the grand finale of PEMDAS. This is the objective where if there are still any PEMDAS people out there, today is the day I change your mind for good, and you will be PEMDAS for the rest of your life.
Forever.
And that is because we are going to be solving equations that have radicals in them. And just like any other equation that we solve, we use opposite operations. Right? To undo subtraction, we add. Undo division, we multiply. Undo a radical, we are going to use an exponent. Okay? However, with radicals, you need to watch out for something called extraneous solutions.
What's that?
An extraneous solution is a solution you get from actually solving the equation. Logan, not in here. Try
Thomas.
Thomas.
No, not Thomas.
Not Thomas.
Is that Probation Nation head president?
No.
Probation's not real.
Mr. Sappy.
Probation Nation's real.
An extraneous solution is a solution that doesn't actually work.
How is it?
Good question. Okay, we will take a look at some examples of how that happened and what to watch for here. But an extraneous solution is a solution that doesn't actually work. You do the math, you get the answers, but then you plug it in and it doesn't actually make the equation true. Okay, we have seen something like this before. Last year when we did parabolas, when we would, as you know, when you solve for a parabola, you get two solutions because the solutions represent the x-intercepts. In a parabola, most of them cross the x-axis twice, right? But in context, we didn't need both of them. Okay, this is similar to that. If you think back to PO60, okay, this is similar to that here. So anyway, we'll watch out for those. We'll talk about those. We're going to start with the root of 2x plus 2 equals 6. Think opposite operations. What are we going to be doing first? James.
2 minus 6.
6
minus 2.
Boom.
I get extraneous solutions all the time.
It's fine if we.
Okay. Start with the addition and subtraction. Subtract 2 from both sides,
Yeah.
opposite operations, and we get the root of 2x equals 4. Okay? Now,
Did we do this before?
we've not done this with radicals before now. We've done them with exponents, but not with roots.
So we have to get the 2 out of the x alone.
You just be quiet for a little second. Okay? Let me go. Okay.
I was gonna.
So, order of operations now would say we have to undo the multiplication and division, right? Undo the 2 and the x. However, because they're trapped together under the root, we're actually going to be doing what to undo the radical?
X equals 8.
We can't x equals 8 the radical. No, not rationalize.
Yes,
Think
it
opposite operations.
Exponent.
We're going to square both sides.
So can you just add a square?
We're going to square both sides to undo the root, because just like subtraction undoes addition, squaring a radical, as we've seen, like this is nothing new, we've talked about this unit here, it undoes the root. And so what we get then is 2x equals 16, which is 4 squared. Now we can divide both sides by 2, and 16 divided by 2, x equals 8.
Nice shot, Tatum.
Is this extraneous? If we plug in 8 to our original equation, is the square root of 2 times 8 plus 2 equal to 6? Well,
Yes.
2 times 8 is 16. The root of that is 4. 4 plus 2 equals 6. Yes, it checks out.
Oh, so this is yes and
Okay.
check.
So it's basically
Not
like
getting checked.
English or
Yes and
Spanish.
check.
English or Spanish.
Next one. Think, yes.
Like, you're always supposed to do like the opposite of the order of operations, so when do you do the multiplication first before?
Not because it's part of the root. Kind of like parentheses can sometimes change the order. Roots can do a similar thing. Okay? Just like when you're squaring like a base and a coefficient at the same time, it's in parentheses, the root the entire thing first. Okay? We have to release that 2 and the x from the root first. Evan.
So can you just like add a root?
Add a root.
Just like
I
add a
found that
And then figure
Well,
the next one out.
Yes,
You didn't get rid of
we are adding the two, we're squaring both sides, because that's what undoes the root, and doing the same thing to both sides of the equation keeps it balanced. Yeah. The next one, 3 root x equals 27, what are we gonna be doing first?
Opposite of.
We subtract 3.
Not subtract 3,
27 minus 3.
Same thing.
divide by 3, we're multiplying
Oh, yeah.
the 3 and the root x together.
That's how I got 576.
So we're dividing by 3 to cancel that out, and we get root x equals 9. Now, to undo taking the square root of x, we are going to
Square.
Oh,
square.
wow.
And we do that to both sides. These operations cancel out, because squaring a root, opposite operations, undoes it, and 9 squared, x equals 81.
I'll leave that off.
I'm calling it.
My word of reaction.
It worked.
I'm already calling it.
It's not extraneous.
If we were to check this and plug this in, the root of 81 is 9, 9 times 3 is 27. This is not extraneous either. Okay?
Calling it. The next one's extraneous.
Do the next one on your own, see what you come up with. Remember,
Make it as good.
even though the order of operations would say to undo the subtraction first when solving an equation, because it's trapped under the root, you have to undo the root first, which you really can't, well, I didn't say you can't, which we won't do until we get rid of the coefficient. Okay?
Oh, yeah.
Can I use a calculator? It's 400.
I encourage you to try without it.
4. 20 times 20 is 400. Where'd you get 20?
Check my
What do you
answer.
do with the vote?
What? Well, whoopsie, whoops.
I got 20. Everybody cheer for me. Hey, wait, we gotta make sure it's in the trees.
X equals 20.
Yeah, right.
It's 20? It's not extraneous. It's not extraneous, Gus. Read.
Okay,
Yes!
The next one is extraneous. I'm calling it.
Yeah, that looks a little extraneous.
So it ain't even that.
Next one.
Well, equals x, what is x?
Okay. Walking through this one. First, we would actually divide by 5, okay? Because we can't square, because it's got that coefficient. We can't do the plus 4 because it's trapped inside the root. So really, we have to get the root by itself first, okay? So divide by 5, that's going to give us the root of x minus 4 equals 4. Now we square both sides to cancel out the root. That gives us x minus 4 equals 16. Nothing changes inside the root. We don't square x, we don't square negative 4 because the operations are what cancel out. Right? The root, the power, they cancel out. So we get x minus 4 equals 16. We add 4 to both sides, and 16 plus 4 equals 20, which, if you plug it back in, 5 times the root of 20 minus 4. Well, order of operations, now evaluating the equation, 20 minus 4 is 16, root of 16 is 4, 4 times 5, 20, it is not extraneous, it checks out.
Great job, Gus.
Alright? Questions on those 3, because now we start getting to the fun stuff. That was just the appetizer.
Is the next one?
Okay?
The next one is the one under the root.
No, the one is not part of the root on the first one in the second row.
No, I mean
Anyone still need the notes?
the root not.
Okay? Good? Okay. Next row, here we go. The root of 5 minus x minus 1 equals x. Okay, so we have variables on both sides here. Right? But because that x on the left side is trapped under that root, we can't move it over until the root is gone. Okay? So what are we going to do first here?
Guess and check.
No. Horrible.
7.
Yeah.
You're gonna add the one.
Going to add the 1. Okay?
Don't you
Because-
get X on the other side though?
What's that?
Oh, it's
Don't you
that
get
one.
the X on the other side of the equation?
We can't while it's trapped on the root. Right? We can't add x to both sides as the first step because this is not an x, it's the root of x. With that 5 minus in there also. So your goal when solving a radical equation should be to get the root by itself so you can do the squaring. Adding 1 to both sides here gives us the root of 5 minus x equals x plus 1. Oh, gosh.
Hold on.
Our next step, now that we have the root by itself, is to square. And when you square the left side, of course we know what happens, right? The root and the exponent cancel out. We're left with 5 minus x. On the right side,
PO15.
what are we squaring?
Oh. Yeah.
Both of them.
English or
Oh my.
Hello, old man foil. Hello, crab
So
claw.
weird.
Hello,
So
box method. It's all coming back.
So
What the frick?
It's all coming back.
Oh, I don't like your intros, my guy.
So go ahead and foil crab claw box x plus 1.
I just love. Wait, is it just like X? Yeah, like that.
Or you can do it mentally. It's x squared.
The box.
Right? What this really means here, this is x plus 1 times x plus 1. Foil crab claw box it. We get x squared
X squared
plus
1x plus
2x.
plus 2x.
Wait, I thought you multiplied it. Wait, never mind. My bad.
Mr. Robinson, were you a old man foil fan? Were you part of the crab claw crew, or did you prefer the boxing method for multiplying 2 binomials together?
Boxing.
Boxing. That's what most
So x
most
squared plus
yeah.
x squared plus 1x. Yeah. Yep.
Right? Now, we've got all these x's here, right? And we have a quadratic equation. That x squared tells us that, which brings back things like quadratic formula, factoring, all those things from algebra, okay? But in order to do this, what does the left side of our equation have to equal?
X.
0, right? We can't solve a quadratic equation until it equals 0. So, we do have to both subtract 5 and add x to both sides here.
Wow.
So we get
Where did I lose you, Emmeline?
everywhere. X squared
Everywhere.
plus
Where did I lose you?
X.
You lost me at the 2x.
You kind of lost me at the start.
Okay. Do you see why we added 1 to both sides?
Yes.
Emmeline?
X.
Do you see why we added 1 to both sides here?
No.
Yes. Okay. Do you see how that gave us x plus 1 on the right side? No? Well, if I'm adding 1 to x, I can't combine x and 1? Because 1x is 1 times x. I'm adding 1 to x.
Where did you see the answer?
Right? So now, these cancel out, we're left with 0 on the left side, which is good. And that gives us x squared plus 3x minus 4 on the right side.
Okay, is this like is this the same method for everyone? Where does the x go? Okay, good. Why is it only like 8x? Oh, it becomes 3x.
Hands in the air, got questions? Emily?
Why does the 2x come?
The 2x, did you foil crab claw or did you box? Box. So in your box, you've got x and 1, x and 1. You should have x squared, right? 1 times x is x, or 1x. 1 times x is x, or 1x. And then 1 times 1 is 1. Then you combine the 1x and the 1x, you get the 2x. All right. Audrey. Where to start? A good rule is to get the root by itself, okay? Because ultimately whatever's under the root is trapped there until you square it, and you really shouldn't be squaring until the root's by itself, okay? So Hold on. So here, the root of 5 minus x, Audrey, the root of 5 minus x minus 1 equals x, right? I said your plan should be to get the root by itself. That means we want this alone. We add 1 to both sides to get rid of this. Because once we do that, once we get rid of that minus 1, now the root is by itself. Right? No?
I got it. So is that the final answer?
It's just like if the root were a variable, like its own variable. If this was n plus 1 equals 7, and I said get the variable by itself, you subtract 1 from both sides, right? Okay? Or I should say n minus 1. If this was n minus 1 equals 7, I said get n by itself, you add 1 to both sides. Kind of the same thing here, only it's not an n, it's a root. Okay? If you want to get that root by itself, you get rid of everything else that's around it. Which in this case, it's just adding 1 to both sides to cancel that out.
So is that the final
Right?
answer?
So, Audrey, what would we do here, in this one, to get the root by itself? Okay, here's the root we want to get by itself. This positive 4 is the problem. How do we undo adding 4? So that would be your first step. You subtract 4 from both sides to get the root by itself.
We're on the next one?
Okay? No, we're not. We're not done with this one yet.
I gotta solve it.
Yeah, we aren't finished
No,
yet.
I don't have any more space.
This is one where you want to probably use the blank sheet of paper right across the way from your binder if you running big.
Who created it?
Oh, I just guessed the
3, 2, 1. You are quiet. Aiden.
Why do you react to the 2x
minus
squared when you have an x?
Because with addition, if you have 2 x's, you have 2 of something, and you add 1 more of something, now you have 3 of something. Right? X is tacos. You have 2 tacos, you get another taco, now you have 3 tacos, right? The difference is, folks, hey, quiet. If you have 2x times 1x, this is going to be 2x squared because you're literally taking x times another x. Remember, exponents are for repeated multiplication. If we're adding x to 2x, we're not repeatedly multiplying. We're taking 2 of something and getting 1 more of that thing. Now we have 3x. This down here would be 2x squared because you'd multiply the coefficients together, 2 times 1, and x times x gives us 2x squared. So it's the difference between what addition means and what multiplication means when it regards to variables. Okay? This is very algebra heavy. This is like I said, this is the grand finale of pretty much your entire algebra year. This is not algebra 2, this is algebra. Yeah. No, we're not done yet. But I want to make sure that folks understand, and this is a PO, by the way, so this is one that you need to pay attention to. I need to understand that folks understand how we got to here.
Oh, I just guessed
Image,
the
time
check.
out. James? Anybody have questions on how we got to that point? Okay.
Yes.
Well, what am I looking at right now?
What I just boxed, James.
Oh, why is there stuff under there?
See, if you zone out for even part of it, it's not going to go well.
No!
Not going to go well for you.
Dad, oh, well, you've been explaining it, so I know.
Okay. So now we're here. You may need to go over to the other side of your page. That's all right. Okay.
That's not the answer?
Nope.
Gotta give it.
We didn't solve Brexit.
X is 1. This doesn't make sense.
Evelyn, I just asked if anybody had any questions on how we got to that point. It doesn't make sense.
I don't know where to ask the question, it just doesn't make sense.
Fair enough. Fair enough. You know what? Why don't we call it good for today? Let's all make, no, don't clap yourselves. Let's all make a pact that tomorrow is 6 hours. We're gonna come in. We're gonna put all other distractions away. Maybe put a chair between us and a friend if we like to chat. and really just focus on what's being done. Because as you have seen,
Okay.
any step, Luca,
I just guessed.
Ken, Emily, Luca, any step can lead you astray if you're not paying attention to what is going on. And once you lose one step, then all the rest of it starts to not make sense as well.
I zoned out when we were
James,
talking.
I never asked.
Oh!
Never have I asked.
And I thought we were-
All right, folks, that's kind of how you math.